Okay, let's do D. Sine of theta is a half. So, well, let's first look at when does sine get you a half. I don't know where this thing is anymore. Okay, sine is on the right-hand side. A half, oh, here we go. It happens at 30 degrees. All right. So I'm doing a lot of scrolling here, but 30 degrees is my reference angle. And so you just draw it. Sine is, there's 4 quadrants. Sine is positive in 2 and negative in 2. And I'm looking at positive a half. Sine is positive in the all positive and in the S quadrants. So I have an angle that's here and I have an angle that's here, both of which have a reference angle of 30 degrees. And I want to know, well, what is my actual angles here? So if this is 0 and you go up 30, your angle would be 30. This is 180, but you haven't gone quite that far. You've gone 30 less. So 180 less 30 is 150 degrees. So you can say theta is equal to 30 degrees and 150. So hopefully we're starting to see a little bit of a pattern here. Tan of theta equals -1. So we're looking for the green in my chart now. When does tan equal 1? Right here. And that happens at 45 degrees. Okay, so 45 degrees is my reference angle. My reference angle is 45. And I've noticed here that it's negative. So tangent is negative. We got to figure out where's tangent negative. Well, it's positive in the tan quadrant, so I don't need that. And it's positive in the all positive quadrant, so it's not there. So tangent would be negative in those 2 quadrants here, in the sine positive and in the cosine positive. So I know I'm here. And I know my reference angle is with the x-axis, so that's going to be 45 degrees. And this right here is going to be 45 degrees. And then the question is, what are my actual angles? So you can start labeling. I label this as 360, and it's less 45, so 315. And I label this as 180, less 45 is going to be 135. So my angles are 135 degrees and 315 degrees. Lastly, cos of theta equals √3/2. It's a positive √3/2. So when does cos give me √3/2? Cosine is on the left. So, right here, 30 degrees. So my reference angle is 30 degrees. 30 degrees. And there's only 2 quadrants where cosine's positive. So cosine's positive here and here, in the all positive and in the cos positive quadrants. So those are going to be gone. And I've got some angles here, and I've got a reference of 30 degrees. So this is a reference angle of 30 degrees. This is a reference angle of 30 degrees. So what are my actual angles now? What are these angles? Well, if I label this as 0 and I go up 30, then I'll be at 30. And because I'm in this bottom quadrant now, I'll label this as 360. And there's 30 below, so 360 less 30 is 330. Not 333, but 330 degrees. So I can say theta is equal to 30 degrees and 330. So I can just zoom out here. There's those 6 questions, and they're working backwards. So if you compare them to all of these ones, here we had, I gave you the angle, so I gave you the 120, I gave you the 315, I gave you the -300, and then we asked you to look at the chart and find out the reference angles. Find out the exact value. And then, so you know, they weren't on the chart, so you had to actually use the reference angles instead, and then you had to use the cast rule. Now I've given you the exact value. It is -√3/2. Now what angle would get me that? Well, there's 2 possibilities where sine is positive. there's always going to be two where sine is positive and two where sine is negative. And I'm looking in this one for when sine is negative. I'm looking at this one for when tan is negative. Looking for this one when cos is positive. It doesn't show a plus sign, but it is positive. So you got to find the two angles. So the very first step for all of these ones is find your reference angle, draw your angles in your two quadrants that you're required to draw. So in the last one I was required to draw in the top right and the bottom right. And the reason it was because those are the only times where cosine is positive, in the top and the bottom right. And then draw your little reference angles and then find out your original. What were your original angles? So it's all working backwards. The idea is you would have no calculator for any of this. So you're going to do a lot of practice, and there is a bunch of examples. And this is something that we will later on do in grade 12 as well. But this is the end of this sort of stuff for trigonometry.